Okay, so in this video, I want us to go through an example of the first theorem in circle geometry. Okay, so in the diagram below, we have O, which is the center of the circle ABD, and F is the midpoint of AD, such that DOF, the line DOF, is perpendicular to AB. AB and FD are equal. They are equal to 8 centimeters, and OF is X centimeters. Okay, and here what we need to do is actually find the length of the radius. So let's quickly just recap what the first theorem states. It says, if a line is drawn from the center of the circle and it's perpendicular to a chord, it will bisect that chord. In this example, we won't have to use that theorem because it's already stated that DOF is perpendicular to AB and that F is the midpoint, meaning that it bisects the chord AB, such that AF is equal to FB. Now, to find the length of the radius, here's how we're going to start. The length of AB was given to us as 8 centimeters. Now, since FB is half of AB, FB will be 4 centimeters. Okay. Now, FD is also equal to 8 centimeters. And we can see there that the line OF, so part of that line FD, is X centimeters. So this makes the remaining portion of the line OD 8 minus X centimeters. Does that make sense? The whole line is 8 centimeters and some portion of that line is X centimeters. That makes the rest of the line 8 minus X. I hope that makes sense. Now the line OD is a radius. So it's equal to OB, which is also a radius. And since we have two, we can refer to them as radii. So that makes OB also 8 minus X centimeters. Okay, now I want you to zone in on the triangle OFB. Okay, I'm going to color this one in red. Notice that's a right angled triangle. If we make use of the Pythagorean theorem, we'll be able to solve X. And once we have X, we'll be able to calculate the radius because the radius is 8 minus X. Okay, so let's use Pythagoras to calculate X. So we'll start off by saying OB squared is equal to FB squared plus OF squared. Okay, now let's do the substitution. Let's remember not to forget our reason, Pythagoras. So OB is the X minus 8 centimeters. FB is the 4 centimeters. And OF is the X centimeters. Okay, so you substitute these lengths and we're going to be multiplying out. So the 8 minus X squared becomes 64 minus 16X plus X squared. If you forgot the shortcut method to square out those brackets, you can just do it the long way. You'll still get to the same result. Then 4 squared is 16 and X squared remains as it is. Notice now if I take the X squared to the other side, it will cancel with the other X squared. So I'm just going to go ahead and cancel that X squared. We'll be left with the negative 16X on the one side, and then 16 minus 64 is negative 48. Divide both sides by the negative 16 and you get X equal to 3. Okay, now that we know that X is equal to 3, the radius has to be 8 minus 3, which is 5. So therefore, the radius of the circle is 5 centimeters, and that's your answer. For this first theorem, there are 3 important things to remember. First, it's the theorem itself. Line from center, perpendicular to a chord, will bisect the chord, and vice versa. Then we need to remember radii are equal. Any radius on the circle will always be equal to another radius of that same circle. And lastly is Pythagoras. We need to remember that we can always make use of the law of Pythagoras in right angled triangles. Those 3 theorems will often repeat itself when you are practicing this first theorem of circle geometry. Okay, I'll put 2 examples here on the screen and you can attempt them using the tools that I just gave you. Okay, good luck and keep well.